part. So, all right. I'm recording this because I think Carolyn and Zeke wanted me to. So we got here, and then I was talking about what I would have guessed and blah, blah, blah. Okay. The one cancels. I think where I was at is if you are putting this in, you're still getting infinity over infinity, so it's still indeterminate form. Okay, let's go again. Let's take the derivative of the top. The derivative of this would be 3e to the 3x times 3 plus 0, right? Which would give me 9e to the 3x. On the bottom, it would be e to the 3x times 3 plus 1. Once again, I'm still getting infinity over infinity. We just got to go one more time. If we go one more time, we get 27e to the 3x, 9e to the 3x. Now I'm not killing cats. Now I can cancel that. 27 divided by 9 is 3. So we just needed to keep going on that. Okay. The other one, oh, this stupid Riemann sum. You know what? I was doing Riemann sum stuff, and I was way overthinking this. Okay. So, this is what I was trying to do. You know how I showed you to go back and forth between like integrals and limits, okay? And I have to circuit about that too. We just run out of time. I mean, there's too many things. I can review that today because sometimes there is one question on that. But this question is just getting at that if I wanted, let's say I have 0 to 2. I don't know what it is, okay? This is f of x. Here's 0, here's 2. And what we did was we started breaking these into rectangles, right? Agreed? And then we said, well, what if I made the rectangles half as big? Right? So what we were doing is we were figuring out the height of these rectangles, and we were trying to make n approach infinity. Agreed? Okay. That's all this is getting at, that if this is written in terms of n, we need to figure out the limit of this as n goes to infinity, and that's the limit as n goes to infinity is going to give us the actual sum. Okay, so let's go ahead and just multiply this top out. What do we get when we multiply the top out? We get, I'm going to just multiply, and then I'll multiply everything by 2. Don't we get 3n squared? Plus 2n plus 3n is plus 5n? Plus 2. Do 2 on the outside, and then we get n squared. Okay. Now, we have 6n squared plus 10n plus 4 divided by n squared. Okay, you following so far? Now, I am going to simplify that further. I'm going to divide everything by n squared. So that would give me 6 plus 10 over n, right? Plus 4 over n squared. Agreed? Now, what is the limit of this as n goes to infinity? Well, it's just 6, because we've talked about when you put a really large number on the bottom of a fraction, that just makes that drives this to 0 and this to 0. And so then the limit of that would be 6, which is why it was letter B. Cole, did you need a thing to grade? Okay. Oh, sorry. Okay. So that's where we left off. Do you feel like we were good with the non-calc? Is there anything else? Now I have a couple more people who have finished. So Mohammed and Owen, anything you guys want to do on the non-calc section? Or do you want me to let you think? Okay. All right. So I'm gonna then move on to the calc section. So you're gonna want to cut out, and then we can go back if need be. All right. Lay them on me. This was harder, you said, for you, right? No. You said it. You did, right?
I didn't think the other side was harder.
Didn't you get more wrong on this one, though?
Well, in percentages.
Yes. Yeah. Oh.
I got 40% wrong in the back, and then 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. And then 36% wrong on the front.
Okay.
So about the same.
About the same. Okay, graph analysis. The graph of a function is shown. This is f. Which of the following could be the graph of the antiderivative? Okay. Which means, what's the relationship? This is gonna be represent what kind of slope this has. Okay. So, let's see here. So over here, if this is below the x-axis, okay, that means that I'm looking for a curve that is sloping down or decreasing from -2 to -1.5. So, you're saying that might get rid of some things? Yeah. Okay. All right. Now, this slope is positive all the way through. So the slope is 0 at -2.5. And then this is going to be increasing from that's -1.5, isn't it? Sorry. From -1.5 to 1.5, and then it's going to be 0 again, and then decreasing 0. The slope is 0. This is the slope. So a slope of 0 means a flat, right, piece? That's what it means. Then decreasing from 1.5 to 2. Okay. Slope of 0 isn't it increasing? Where did we say it was flat at? It has to be flat at -1.5. 1.5, but another flat? Okay, this is also flat there and there. Okay, hold on. So, and then decreasing from 1.5 to 2, increasing from negative, it's got to be D, right? Because this is increasing the entire way. This one's not increasing the entire way. So, all right. What else? Okay. So, when you're given the derivative on the calculator section, you can go ahead and graph it, and it's asking for relative, which means I don't have to check endpoints. Okay, so if I have the derivative, which I have, so the function is going to maintain a relative maximum when the derivative switches from positive to negative. Okay, so let's get our calcs out. That's what we're looking for here. In parametric mode earlier. So we have, I'm going to put this in parentheses, x cubed minus 8x. I always do that. Divided by x cubed plus 1.
That's my graph look like that.
What's going on? Okay. From negative 1 to 9. Okay, so I'm going to go ahead and put negative 1 to 9 on. I'll change my x min and y max to negative 10 to 10. Okay. So, at what value of x does f, where does this switch from positive to negative? Right there, right? That's 0. We all know how to use the calc to do this. Or you can do intersect with like graph 0 and make it intersect. So should be 0.638, letter C. What else we got, guys? Okay, let f be the function defined by ln x squared plus 1. Let g be the function defined by x to the 5th plus x to the 3rd. The line tangent to the graph of f at x equals 2 is parallel to the line tangent of the graph at x equals a. Okay, tell me what that means in terms of calculus. Parallel lines mean same slope. That means the derivative of f prime, because that represents the slope, is equal to the derivative of g prime of f at 2 and g at a. What is the value of a? Okay, now, did you know that that's what you were doing?
Yeah.
Okay. On this, the issue is that you can use your calculator, but I want to figure out when these two are equal, and I can use graphing to do it, but you do have to use computation to do the derivative before that. You can't use n-derive because well,
I did.
you can use n-derive with this because you can figure out what it is at 2, and this is pretty easy to take the derivative of. Let's do that. Let's do n-derive with f prime and plug 2 in, and then we'll set that equal to the derivative of g, which that's super easy. It's way easier to derive than ln of x squared plus 1. All right, so we got ln x squared plus 1 at x equals 2. Is that what you got for that? 0.8.
Yes.
Okay. I'm going to leave that in there. So I know it's essentially 0.8. Okay. And we're going to do g prime of x, 5x to the 4th plus 3x squared. Yes? If you want to solve it graphically, you can do it graphically, I think. That probably is the easiest. I mean, you can solve it algebraically and take out an x, that's yuck, x squared, and you could, but if I have my graphing calculator, I'm just going to put 0.8 in one thing, and then 5x to to the 4th plus 3x squared. Okay, what else could you do at this point? Don't you have these answers? Couldn't you plug them in and see which one gave you 0.8? Right? Because you have all the choices there? Okay. Let's graph. Let's see if my window's okay from before. Okay, it looks like there's a negative and a positive. I'm not going to even do the negative because bam, bam, if there's not a choice on there that's negative. Move over. Well, it's not moving over. 0.447 should be letter C. Yep. Tell me what went wrong here.
I didn't even know what to do on this one.
Okay. Mm-hmm. So, underline things, okay? Underline things, write things down. Parallel means same slope. Slope means derivative. Okay, some of those words. All right, what else do we got? 86? 96. 86. Ooh. Twice differentiable functions f, g, and h have the second derivatives given above. Which of the functions f, g, and h have exactly 2 points of inflection? Oh, yay! How do we tell points of inflection?
When it switches.
When what switches? When the double derivative switches signs, right? So let's just graph these all and find out which ones have 2 points of inflection. Oh, could you do a sign chart? Sure, but we have our calculators. Let's just graph these. And this is why you have 45 minutes on this section, right? But they take, a lot of these take longer when you have to graph them to find the answers. Okay, plus 2 to the 3rd. Now, be careful, this is a common mistake. Inflection points are where the concavity switches. So we're not just finding zeros, it has to switch signs, okay? So be careful of that. Okay, there's my first one. I don't have a good enough window. Let me do negative 10 to 10. See it a little better. Okay. This is a sign switch right here, right? That's 1. Sign switch right there, 2. That's where people are going to get this wrong because they're going to count this. This is not an inflection point. It's just where the double derivative is 0. This one has exactly 2 points of inflection. Okay. These are just adding this graph up and down, but let's go ahead and add 1 to it. If I add 1 to it, it's going to shift that graph up. And this still has how many points of inflection? 2. So this, it's going to be this. That means, well, maybe it is. No, I don't think so, because I think when I move it down, it's going to move that 1 to a 3rd. Okay, this becomes 3 points of inflection. 4. 1, 2, 3, 4 points of inflection here, doesn't it? Okay. So it should be F prime, double prime, and, or F and G only. Letter C. One. Let f be a continuous function for all real numbers. Let g be the function given by g of x equals the derivative from x to 1 of f of t dt. If the average rate of change of g on the interval, I didn't say the average value of g. Notice I said average rate of change. That's where people can get tripped up. Which of the following statements must be true? Okay, now, let's figure out what the statement is for average rate of change of g. That is not a calculus thing. And what we're going to do is we're going to figure out which of these statements equals that, essentially. Okay? So the average rate of change of g is g of 5 minus g of 2 over 5 minus 2. Not a calculus thing. Are we good with that? Okay. and it's telling me that this is equal to 6. Okay. Okay, so the question is the average value of f on the interval from 2 to 5 is 6. Okay, well, let's check this. Let's write the function average value from 2 to 5 of f of x over 3, right? You see where I'm putting it over 3? Okay. Is that equal to 6? Okay, so let's figure out, is that the same thing as this? In other words, is this and this mean the same thing? Okay, so what's the antiderivative of f? G. And how would I use fundamental theorem of calculus? I would do g of 5 minus g of 2 over 3. Aren't those two things the same thing? Okay, so this statement is true. Okay. Does g prime of 2 equal 6? Oh, this has so much fundamental theorem of calculus in it, doesn't it? The derivative, let's go ahead and do the derivative. What happens when we do a derivative of an integral? Cancels. So g prime of x is the same as f of x. So does f of 2 equal 6? I mean, we don't have any way of knowing that, I don't believe. I don't think. I don't know, I didn't look at the answer. G prime of 5 plus, I mean, I guess we could check. This isn't true because the antiderivative of g wouldn't be g, right? To do this, you'd have to do antiderivative of g, plug in 5. Well, and do we even have the antiderivative of g? No, so we don't know that either. I think it's only a. Am I right? Okay. This is like, people get confused with this because they think they're looking at this is never anything we do in calculus. They're essentially averaging the derivatives together. We don't ever average derivatives together, so. Tricky. That was a hard one. The last one. Oh, yay! Let's talk about this. Okay. Couple statements. To be continuous, we heard Virgin Mark talk about this. To be continuous, there has to be a limit at the point. And in order for there to be a limit at the point, if it's piecewise, the left and right have to exist, okay? The function has to be defined at the point. This is to be continuous. Okay. And then those two things, the third thing is they have to equal each other, okay? That's the three, we call it the three-prong test, we meaning math teachers, call it the three-prong test for continuity. So, also, differentiability always means it's continuous, but the reverse is not true, okay? That's the only things we know. Okay, let's look. If f is defined at x equals a, then the limit of these two things is the same. Is that true? Can I draw a graph for you? Here's A. Here's a point defined at A. Here is a graph that would make that not true. The function's defined. That doesn't mean anything about its limit. So that does not have to be true. Okay. If f is continuous at x equals a, then the limit as x goes to a of f of x equals f of a. Yeah, yeah, that's true. That's the definition of, that's one of the three things that has to be true. If f is differentiable at a, then the limit as x goes to a. Okay, now differentiable doesn't tell you anything, but differential tells me this, right? If it's differentiable, it's continuous. So let's, in our head, say, okay, we know it's continuous. If the function's continuous, does the limit have to equal the defined point? Yes, okay. So 2 and 3 have to be true. Should be letter C. Okay. Good? All right, how are we doing, guys? Anything else?